So if this substrate is treated with LDA at minus 78 degree centigrade, then what will happen here? The kinetic inlet will be formed because the temperature is low. So first, if it is treated with LDA, then the kinetic inlet will form, that is, this hydrogen will be taken by LDA. So the corresponding inlet will be formed. Now PHACCl, so it will attack to this simple SN2 reaction will occur. So SCPH. Now if H2O2 is given, then it will oxidize. So it will be O minus. Now this hydrogen, if it is heated, then a chain elimination reaction will take place. So this hydrogen will be taken and an elimination reaction will take place. So here an alpha beta unsaturated ketone will be formed. So this will be the product. Now the next question, if this is treated with this and RH2OCl4, then what will be the product? In this reaction, what will happen? Here the two hydrogen, which are quite acidic, it will undergo analyzation. So now in this compound, decision let's say this is R group. So what will happen? It will attack here. So C-double-O-B-N, here N, double bond N minus. Now this hydrogen will be taken by this nitrogen, so it will be NH. Now here another hydrogen is there, so this hydrogen will be taken by here will be hydrogen. Now here it will be double bond N, triple bond N. Here a positive charge will be there, C-double-O-V-N, and this hydrogen will be taken. Here a hydrogen will be there, and this NH will take this hydrogen, and the C-double-O-B-N, here it will be double bond N, double bond N. Now if it is treated with RH2OCl4, then it will be converted to a carbene, and this carbene, here the nitrogen lone pair will attack that carbene and an insertion reaction will take place, CH insertion reaction. So our product will be So this will be the product. Now we have to determine the enantiomeric pair between this. Now in this compound, as this is a plane of symmetry can be passed through this molecule in this way, which bisecting this CH3 in this way a plane of symmetry can be passed. So this is optically inactive, so this is not these two are not enantiomeric pairs. Between these two, if we compare, here the hydrogen is below the plane, here the Cl is below the plane. So if we rotate this molecule, then the Cl will go below the plane, hydrogen will come above the plane, and on the other hand here the Cl will be here. So if we rotate this, we'll get the Cl will go below, hydrogen will come above, and here will be Cl, it will be hydrogen. Now if we compare this two, then we can see that this part is not mismatching, not matching with this. So these two are not mirror image relationship, these two are not enantiomer. Now between these two, here as we can see that here the carbonyl group is here, but another carbonyl group is in this side. So if we place a mirror plane between these two, then these two are not mirror image to each other, so these two are not also enantiomers. On the other hand, in this compound, if we rotate this in this direction at 180 degree, then the COOH group will come here. If we rotate this, then what we'll get? COOH group will be here, NO2 will be here, and here the COOH, here NO2. Now if we compare between these two, then if we place a mirrored here, then this is the mirror image of this. So these two are mirror image relationship, so these two are enantiomer. So the option 4 is correct. Now the next question, here in this substrate, if it is treated with potassium tertiary butoxide, then what will happen? Here the 2CH3 group is there, and here also one hydrogen is there, and this group is above the plane. So this potassium tertiary butoxide will take the most acidic hydrogen. Now between this hydrogen and this hydrogen, which one is more acidic? This one is more acidic, because this is 1 degree and this is 2 degree. So what will now this potassium tertiary butoxide base will abstract this proton, and the corresponding sulfur halide will be formed. So here will be a minus charge, here will be a carbon. Now there will be a 1,4 addition reaction here, so it will attack into this carbon, and it will come from above the plane, because this is above the plane. So the result will be now if it attack here, here is this. Now when it will come back, it will attack into this carbon, Here a positive charge is there, and this bond will open up. So here a cyclopropyl ring will be formed. It will be double bond O. This is SCH3. Now if it is treated with Raney nickel heat, then this bond will be cleaved. It will be converted to a CH3 group. So the product will be this cyclopropyl ring will be above the plane, and it will also be above the plane. So this will be the product of this reaction. Now another question: if this compound is treated with HNBU3, then what will happen? Here a coupling reaction will take place. So here these two moieties will attach to this, and a coupling reaction will take place. This coupling reaction is known as delay coupling. So what will happen? Here double bond O, Me. Now this part will be attached with this, so it will be a diene. Now if it is heated, then what will happen? Here as you can see that this is a diene, and this is a dienophile. So what will happen? A Diels-Alder reaction will take place. So this, if we draw this in another way, then here we'll place this here a BOC Me. So it will attack in such a way 4+2 addition reaction will take place, Diels-Alder reaction. So here a 6-member ring will be formed. So the product will be here a 6-member ring, as well as here a 6-member ring, and it will be a 1 2 3 4 5 6 another 6-member ring. Another 6-member ring will be formed here. So now here there will be a connection between this and this. So now this carbon, there is a CO, here the nitrogen Me, and a 5-member ring will be attached with this 6-member ring in this way, in this carbon. So it will be here, and here will be a pi bond. This pi bond will be here. So this will be the product. This is the Diels-Alder product. Now another question: if this compound is treated with O3 H2O2 and then H3O plus, then what will be the product? Actually the question was asking about the number of carbonyl groups present in the final product of the following reaction sequence. So what will happen here, after ozonolysis this bond will cleave and it will be converted to CHO, but as the condition is oxidizing condition, so it will be converted to COOH. So after ozonolysis the product will be CH2, this will be CH2 COOH, here C double bond of CH2 COOH, and then it will be as usual. Then if it is H3O hydrolyzed and heated, then this decarboxylation will take place. So this CO2 will removed, as well as after hydrolysis this will hydrolyze to COOH group and it will also be removed to as CO2. So the remaining in this, the product will be, it will be CH3, and this will be hydrogen. So the number of carbonyl group will be 4. And another question is the strongest band observed in the IR spectrum of the final product of the following reaction. So if it is heated, then what will happen here? A 3,3 sigma tropic rearrangement will take place. 3,3 sigma tropic rearrangement. So OH, now this will be tautomerized to carbonyl. So this is a keto group. So keto group has generally stretching frequency at 1710 to 1715, 1725. So this will be the answer. So now this allyl radical, this is an allyl radical, so it will go into resonance. Now here this radical will attack here, so a 5-member ring will be formed here. Now this radical will come into resonance. So here now this two radical will dimerize to form the product, this. So this will be the product. Another reaction, if this substrate is treated with potassium hydride, then what will be the product? This is the Peterson reaction. So what will happen here? Here first this hydride will take one of this proton and it will be converted to O minus. SiMe3, this is O minus. Now the which group is actually above the plane. So what will happen now, we have to rotate this carbon-carbon bond so that this this O minus will come go below the plane, so that SiMe3 and O minus will be on the same side. So here it is below the plane SiMe3, and it will be rotate in this direction. So 1 2 3 1 2 3, it will go into below the go below the plane, so it will be O minus. Now a 4-member ring will be formed. O minus will coordinate with Si, so a 4-member ring will be formed. SiMe3 O. Now this will cleave and the corresponding alkene will formed. This has Z configuration, so this is cis alkene will be formed. This reaction is known as Peterson reaction.